The third learning objective in Section 5.7 is to interpret output from a statistical program and/or calculator to carry out a hypothesis test for two proportions or to interpret a confidence interval for two proportions, for example using GeoGebra. A researcher believes that children who attend elementary school in a rural setting have lower obesity rates than children who attend elementary school in an urban setting. The researcher collects a random sample from each population and records the proportion of children in each sample who are clinically obese. The data is summarized in the table below. Also shown below is the GeoGebra output. Assume all conditions for proceeding with a two-sample z-test for proportions have been met. So this is a hypothesis test for two proportions. Besides the fact that it says a two-sample z-test, we can see that we're trying to analyze whether a claim is correct or not. Also, we have two groups, rural and urban children, and a categorical response variable, whether or not the child is obese. Here is the GeoGebra output. You can see that we're using a z-test for the difference of proportion, and we've entered in the number of successes, which in this case means clinically obese, in each of the samples, and the sample sizes. The output summarizes the data and then gives us the test statistic, which is the z, and the p-value, which is labeled p. This question says that the null hypothesis to be tested is H0 P sub rural equals P sub urban. In other words, that the two proportions are the same. Part 1 says, using correct statistical notation, what is the alternative hypothesis? Well, we have a few different clues. First of all, it says that a researcher believes that children who attend elementary school in a rural setting have lower obesity rates than children who attend elementary school in an urban setting. This word lower here tells us that this should be a left tail test. We also can see that the button next to the less than symbol has been highlighted in the GeoGebra output. So to write our hypothesis, we would write H sub A, where P for rural is less than P for urban children. Next, the question asks us to report the test statistic rounded to the nearest 100th. The test statistic is the z value that is given. The nearest 100th is the second decimal place. So that is z equals negative 1.95, rounded to two decimal places. The p-value is given right below at 0.0258. This question asks us to round to the thousandth place, which is the third decimal place, and so that is 0.026. Next, using a 5% significance level, state the correct conclusion regarding the null hypothesis and the researcher's belief. So our p-value is 0.026, which is less than a 5% significance level, or an alpha of 0.05. And so that means that we reject the null hypothesis and we have sufficient evidence to conclude that the alternative hypothesis is correct. The alternative hypothesis was the researcher's belief. And so we would write something like this. Reject H0, there is sufficient evidence to conclude that the researcher's belief is correct, that children attending elementary school in a rural setting have lower obesity rates than children who attend elementary school in an urban setting. Here's another example, this time for a confidence interval. Because of the concern about the health effects of cell phones, a 2016 National Toxicology Program study tested whether rats exposed to radiation levels emitted by cell phones were more likely to develop tumors than rats who are not exposed to the radiation. In an experiment involving 180 rats, 90 were exposed to radiation and 90 were not. Use the following GeoGebra output to answer the questions. So we can see that a confidence level of 0.95 was entered. We can see the data, and then we can see the lower limit and the upper limit. So the first question says, what is a 95% confidence interval for the difference in the proportion of tumors for rats exposed versus not exposed to radiation? Well, our lower value is negative 0.002, and our upper value is 0.1798. So that's our confidence interval. And next we need to answer this question. Is there a significant difference between the proportions of rats exposed to radiation that developed tumors and the proportion of rats not exposed to radiation that did? Remember that we are dealing with the difference between proportions. So P1 minus P2. If those two proportions are the same, then we would get 0. So for example, if the proportions are 5% for both of them, 0.05 minus 0.05 is 0. If the proportions are 10% for both, 0.1 minus 0.1 is still 0. So if 0 is a likely value for the difference between proportions, then we would say that the two proportions could be the same. If 0 is not a likely value, then we would say that there is a significant difference. Remember that confidence intervals give us a range of likely values. So our likely values for the difference between proportions goes from negative 0.002 up to positive 0.1798. Since 0 is contained in that interval, remember that will always be the case that 0 is in the interval if the interval starts out negative and ends up positive. Then we would say that there is not a significant difference. So in other words, no, the interval contains 0, so the two proportions could be the same.